Is my audio audible now? Can you hear me now? Vikas, Prajwal, Devashish, no? Can you hear me now? Yes? Okay. Awesome. Yes. I was talking to myself for the past minute. But what I was saying is, I'm glad that all of you have come. I'm glad that we are going to be trying to design a system which is going to be an imaginary system, right? None of us work for BookMyShow. None of us know what the internal system looks like, but it will be fun. And so we will try to think of a booking system. We may take the best out of other booking systems, like let's say Ticketmaster, or there's IRCTC. And so thank you, Harry. Thank you, Vivek, Aditya, Rohit. It really matters. Your comments here are the reason why I was able to detect whether there's an audio issue. Otherwise, I would have been speaking to myself for 40 minutes. So thank you. Manpreet is having an interesting suggestion. He's saying, anyone up for making a new company? Book my seat, which is going to be interesting. Yeah, go for it. I mean, Manpreet, you can give it a shot. All the best. But I'll tell you that if you think that this system is very easy to build, we will see in the next maybe 40 minutes whether that is the case. Okay. And TLDR or spoiler alert, I don't think so. I don't think this is very easy to build. Yes, Harry, this meeting will be will be recorded, and I'll be sharing it with you on the YouTube channel itself. Awesome. So before we start, guys, we will wait till 5:10 for everyone to join. Until then, do you have any questions around Book My Show? What I'll do is I'll just give you a rough idea of what we are going to do today. We are going to be trying to design Book My Show. Specifically, we are going to be designing the ticket booking system of Book My Show. Okay, we are not going to be thinking of recommendations. We are not thinking of how do we schedule things. We are thinking of tickets have to be booked for a particular event. How is that going to happen? Okay, and I have a whiteboard which I'm going to be using to describe my thoughts or put them down. Okay, and now I'm going to become really small. I'm going to get relegated to a little corner here. Let me fix myself. Yes. Nice. LLD or HLD, Ahmad, it's going to be the high level design, right? We are going to be looking at it from a partly product angle also. Okay. Thank you, Vishal. Blog and interview ready regarding this is a good read. Thank you, Aditya. I wrote this recently, and then I saw that Book My Show had an issue. So I was like, okay, wow. Yes, so okay, 2 more minutes, guys. Any other questions? Wanted to see how we can handle so many concurrent requests, like 1000 queries per second. Praveen, that's a good question. In fact, let me start writing this down now. Some of the ideas are really, really interesting. So I'll note this down. System design of Book My Show. Praveen brought a requirement to us. He said that there are going to be thousands of queries per second. Anything else, guys, that you can clearly see could be a large problem? Are we considering multi-thread scenario race conditions? Kunal is talking about concurrency, maybe race conditions, maybe not multi-threading. We might look into that also, but we will definitely look into concurrent bookings, which means Kunal is trying to book, Gaurav is trying to book the same seat, and now who has their seat booking go through and who has a apology message. So that's something we'll look into. Vishrud is asking the same question again. I'll just have to put you on timeout, sorry. Guys, let's keep the discussion relevant, right? Otherwise what happens is we'll get lost. So how does a seat appear blocked when a user selects it across sessions? So how does a seat appear blocked when a user selects it across sessions? That's interesting. So what you want to do is, if Gaurav is booking a seat and Saransh has already booked that seat, should Gaurav get a notification on his UI that the seat has been booked? So when we are seeing a seat arrangement, do we see this? Let's say the dark part is booked, so that is updates on booking seats to other customers. Okay, that's a good question. For big user base, which language do you recommend for backend? Again, guys, let's keep the discussion relevant. Live Tech Edition has an interesting point. They are suggesting a solution. They are saying that in IPOs, you have pre-booking or lottery booking or auctions or various things that you can try to do. So there is a particular way in which an IPO happens. Once a company has set a price for a share, you can actually try to book those shares. So you don't actually get those shares, but you show an intent, a payment intent or a buying intent. We will not be going into that much. It could be a potential solution, but we will not be looking at it from a technical standpoint because that's not what is happening right now. Okay, there is no company in the world which is doing this for booking seats in a music concert yet. So we will not be using this, but it's a potential product solution. If you are in finance or if you are aware of IPOs, then you know what we are talking about. I won't go into this in detail because we won't be needing it. Distributed transactions, Vikas is suggesting another solution. Okay. Okay, I'll just do this for 3 more minutes, guys, then we will start off. I'm getting quite a bit of the requirements in front of me. I'm getting potential ideas also in front of me. I think this is a really good requirement, thousands of queries per second. That is a clear requirement. The rest of the things sound like things that engineers tell product managers when they have half heard a problem. But that's because you are engineers and you have a very good idea of what the product is. That's why these solutions are coming up. So they're good, but we will use these. What else? Oh God, my whiteboard is not visible. Oh. Okay. That is very interesting. Let me delete the whiteboard. Thank you for that. Vishal, thank you so much for that. I was not able to see the whiteboard. Kiran, thank you for that. I'll just bring the whiteboard now. So, it's very, very helpful that you're giving me this constant feedback because, hey, why can't you see the whiteboard? What's wrong here? I am drawing on the whiteboard, so that is odd. Just give me 1 second. It shouldn't take too long to capture this. Yeah. Okay. Is this visible now? Yeah, I think so. Thank you. Thank you. This was super helpful. Okay, let me put it down. Yes. Okay. Passive locking mechanism. Okay. Shailaja is actually serious. Okay. So maybe another potential solution which is being discussed is, instead of a distributed transaction, you can have locks, and you can have pessimistic versus optimistic locking. Okay. We are predicting. We don't really know the backend of BookMyShow. That's not in a white paper or it's not publicly available. We are looking at ticket booking systems. They're not going to share the code with you, right? Or their entire business nitty-gritties. Nobody does that. Anything which is core to the business, like Google does not open source search. Everything else is open sourced. OpenAI does not want to open source its main models, right? Twitter is the only company I think which has open sourced its algorithm. Most companies, they open source auxiliary solutions. They don't open source the thing which they depend on as a business. So BookMyShow, from what I understand, is never going to open source this. You'll have to guess. It's time to dance. Database algorithm, you're going to use Redis locks. Okay, one final thing that I'll look into is from Harry C. Accurately tracking and updating ticket availability across multiple channels in real time to prevent overbooking and real time price increases. Yes, that is correct. So let us assume that you won't have price increase as the number of seats are getting booked. This would be an airlines question, which would be interesting. But when it comes to BookMyShow or theaters, you don't jack up the prices when people have booked the seats. You set the price beforehand, and there is no effect on future price if more people book tickets quickly. Okay. If you're talking about overlapping bookings, we have to avoid them. Okay. This is another requirement which I think came up here with race conditions and concurrent booking. Okay, I think this is good enough. Let's start with the system design. Okay, we'll try our best to make sense of BookMyShow's booking system. Any place where you would like to start with? Let's keep it basic. Let's say that you have requests coming into your system. Okay, how they're coming for now doesn't matter to us, right? It's coming from some sort of a browser. We are focused first on the back end, then we will look at the front end. So the request which comes initially as a flow will be get me seats for an event. Okay, so here you'll be passing in the event ID, and here you'll get a seat arrangement in response. If you imagine a movie hall or you imagine a screen in that movie, then it has a set of seats and it has an arrangement that will be sent back to the UI. The seat arrangement in turn has many seats. You can think of this as an array of seats. So a collection of seats. And what is a seat? A seat is going to be something which has a seat ID. So they use this as a seat number. When you're entering the theater, you probably show this is my seat number. At the screen also you show this, so if there's any confusion, then you can just show that ticket and you know that one person can have one seat. There can't be two people having the same seat. Okay. The other thing, is there anything else? Maybe the price of this seat at this time. And so every seat is attached to an event. Okay, let's assume that the same hall is going to have different shows, and each show will have this seating arrangement available, and in that seating arrangement you'll have unique seat IDs. So if Gaurav enters the hall and sits on this seat ID 123, after the show is over and Gaurav leaves, when a new person comes and sits on the same seat, it's going to have a different seat ID. It's going to be 456. Okay, so it won't be that I have to think of the physical seat location. I'm looking at this as a virtual seat. It can be anywhere, and as the show changes, the seat ID also changes. So I'm not worried about this now. Okay, if you want to give a description to it, maybe the description will be K17, K12, whatever. This is the row and column, but in reality the seat ID is different. Just putting it clearly so that we all understand this. Okay. Get seats for event, we get a collection of seats. This is not something which we are very concerned about, because we are more bothered about the booking of seats instead of how are these seats going to be arranged, how are they going to be stored in the database. what exactly is going to happen when it comes to changing shows, not our concern. Someone also mentioned something about emails for confirmation. That is also not our concern right now. We are just bothered about booking. Okay, so once I have a set of seats, what do I get to see on my screen? I get to see this. You can think of these as seats in the theater. So I see this on my browser. And if you see this kind of a theater, then you're probably not going to book seats because it's very, very bad in arrangement. But assume for now that this is what it is and you are really desperate to watch this show. So let's say you want to book some seats. Okay, so you want to book this one, and this one. So the range of seats in row A from 2 to 4, 2, 3, 4 is what you want to book. These are 3 seats you want to book. How do you think this is going to happen? Okay, so on your browser you select these 3 seats. Now what happens exactly? Let's look at this step by step. When you have made the selection on your browser, when you have clicked on those seats and you see them blocked, or you see them as green, or some way to highlight that you want to make this selection, what do you think happens? Akshay, that's a good point. So maybe in the price and description you can have that type of seats, luxury, basic. We are not looking into that. Let's again come back to this point of, you have a seating arrangement, you have the user who's looking at the seats in the browser, clicking on them, and now what happens? They've just clicked on the seats. They've shown an intent to book, but they haven't clearly said, yes, I want to book these. What do you do now? Yes. So Ninja, you're right. Some sort of locking. Okay. Should you do it now or should you do it later? Lock the seat status. Okay. Temporary lock on the seat is going to happen. Okay. State of seats change, TTL for some minutes. Here's the interesting thing. It's very common for you to book these 3 seats and have a friend of yours or your family member say that, no, not these, book the other ones. Move the booking. Go from row A 2, 3, 4 to these 3. You know, you have all these seats put together, you have walking space here and here, book this one. So row B 1, 2, 3 is what you should book. Now if you had booked the seats beforehand, then you would need to unlock them. If you had made that API call when you selected those 3 seats on your browser, that please book the seats, I want to show an intent of booking intent. If you had made this API call with whatever parameters required, then now you would need a way to undo that or unlock those seats. This is unnecessary. So what we are looking at is the way that the users use the product, the way that they access the product is determining how your design is going to be for this product. Okay, if people would have been absolutely sure, if they would have said, once I select seats, I'm 100% sure I'm going ahead with them, then you would have made this API call. That is not the case. Most people don't do this. So at this time you do nothing. On your browser, let the user play around with whatever bookings they want to make. The moment they say book, this is going to be a big call to action. This is going to tell them that you can book, you're going to move to a different screen. That's when you make an API call. Okay, and if they click the back button once they move to the next screen, okay, if they click on the back button, once they have moved from this screen to the back button, this is action number 2. If they do this, then you do the undo, and if they go for action number 1, then you do a booking. Okay, is this making sense? Because you want to make sure that the user is clear on the seat booking before you make an API call. The API call is going to cost your company something, so it's better that we are sure that the user wants to do this. Okay, this is just a product thing. Um, Fine. Let us now say that the user is sure. In fact, if you know BookMyShow, then when you come on the seating arrangement, before you see the seating arrangement, BookMyShow asks you how many seats do you want to book. So it gets a tentative answer of 3, 4, 5. So it knows that these many seats have to be booked beforehand. Okay, we don't need that here. We will just assume that you can book as many seats as you like on this screen. Okay. Once a booking intent has been made, what do we do? Okay. This is weird. My screen. Is not working, but yes, just give me a second, guys. There's something wrong here again. Microsoft Whiteboard, I tell you. I don't know why it keeps happening. I think I should just move to a different software. But it's okay. I'll look into that separately. Yes, this is visible. Okay. Quick recap. You book the seats. You are going ahead to the payment page. On the payment page, before you move to the payment page, before the payment page is loaded onto your screen, you have in parallel made a booking intent request. So Excalibur is a good idea. Yeah. So once you have done this, what is going to be in the booking intent? Let's try to understand the APIs now. What do you need to pass in the booking intent API call for the booking to start? Very good point raised by Webhub. He says that selection of the same seat can be done by multiple people, right? So that's a really good point. We look at that in a minute, Webhub. For now, just assume that there is nobody else who is booking the same seat. Okay. Yeah. Booking intent needs a seat ID. Seat ID is correct. Seat IDs actually is what Harry has mentioned. Shubh has also mentioned that. Aryan has also mentioned seat ID. That's great. Anything else? Not really. User details, login details, all of that stuff, token, that's not included in the API. You just need a bunch of seat IDs which you want to book for a user. That is implicit, but okay, we'll just make it explicit here. Okay, this user wants to book these seats. Simple. Let's assume now that there is no contention, there is no concurrent booking. Once the payment page comes in front of the user and they make a payment, which means they create a payment intent, they finish the payment, it's a success, and they come back, what should happen? The seats should get booked. What does that mean? Just give me a second. Let me look at it. Yeah. Point number 3 is once they have actually made the payment, so they give an order ID maybe. Once that is complete, and then you have item details and stuff like that inside, and you come back to the success page, your seat should be booked. Okay. If your payment fails, what do? You try to retry. You may tell them that you have 10 minutes to do this. Please keep trying. And if the payment page times out, then you send them back to the seat arrangement area. Okay, this is the general flow. We said that there is something called successful booking, which means the seat status has to be updated here. So a seat then has an ID, a price, a description, and it also has something else, which is status. Status may be a set of states you can be in. One is open. You may be booked. Anything else? It may be locked or reserved or anything like that. Okay. So we're just keeping 3 status for now. Open means anyone can come and book the seat. Booked means this seat is no longer available. It doesn't matter who wants to buy it. It's blocked. And there is one which is locked, which means the seat is currently being paid for by some other user. Some user is on the payment page, has shown clear intent to buy the seat, and they are in the process of payment. So it is locked. If they don't make the payment in the stipulated time of, let's say, 15 minutes or 10 minutes or whatever your product manager says is sufficient time to call up your mom and say, Mom, I'm going to this concert. Is it okay? or your wife or your kids, whatever, right? You want to call up maybe your friends and tell them that, do you want to join me in this concert, or I'll get someone else. So stuff like that. You need some time. Maybe you want to see your card. Maybe you want to see the details of your card. Could be anything. 10 minutes should be sufficient. If you don't book the seat in 10 minutes, we move from locked to open position. If you, which is this state, right? State X is logged to open position. And if you are successful, then you move to state, this transition is Y, which is payment to successful booking. This is locked to book position. At a high level, this is what's happening. Okay. So you're going to be managing the seat booking through the status, the seat status. Okay. Someone had mentioned, what if there are multiple people who are trying to book the same seat? So when you're making the API call for booking intent, what's going to happen? That's the whole difficulty behind the booking system at BookMyShow. We'll get to that in a minute. Any other questions that you have? Because we are going to be looking into what happens if multiple people are trying to call booking intent for the same seat IDs, for overlapping seats. There is one other challenge. How do you expire the lock? Okay, so we have 2 major challenges: expire lock, and challenge number 2, which came up earlier, is race conditions, concurrent booking. Okay, this is something which defines the scale of the problem, so that's good. Overlapping bookings are not allowed. Yes, they are not allowed. That is true. So race conditions come here. Should we, this is a product question, should we on booking seats show those updates to the rest of the users? So when Gaurav is booking a seat and Harry is booking a seat, if Gaurav moves to the payment page, should Harry get a notification saying that those seats are now locked? Harry, there's no way you can buy these. Or when Gaurav has moved to success page, should Harry get that notification? The answer is, in my from what I've done in BookMyShow, I've never seen this happen, and it's also a little too hasty. It's going to cost you a lot of network calls. Any person who's booking seats will see a lot of changes happening on screen. You might want to do this for a real-time experience, but it's unnecessary. So we are not going to do this. Okay. If Harry is booking the same seats as Gaurav, after making the API call, he will get to know. The API call will fail, and he'll be again directed to a new screen with the updated seat arrangement. That's the idea. Okay. So our challenges are only expiring locks automatically and managing race conditions or concurrent bookings. Okay. Let's look at the first problem of expiring locks when a person has shown intent to buy a seat, but they don't. Maybe their page timed out, maybe their internet connection went off, maybe they just dropped off. What do you do with these seats? If they want to press the back button, then we know that, they are no longer interested. So you move from lock to open very quickly. So this is also a transition of X. But the challenge is, how do you automatically kick them out of the payment page if they haven't responded quick enough in 10 minutes? Set a lock that. That's a really good point. Yes, Nived, that's a really, really good point. So maybe when you're creating an order, or let's say you have the seat here, you have status, you have some description which tells you the location or the seat number in a particular theater. You have the event ID, you have the price, you have various other things, you have the ID of the seat itself. But one thing which Nived mentioned is when was it logged, so the timestamp. Logged at, which is a timestamp. When you move the status of a seat to locked, okay, which is only possible if you're moving from open to locked, there is no other state transition possible. If you had to draw the state transition diagram of this, you would have open to locked, booking intent. This is the first screen. Okay, from logged you can go to either booked, which is a successful payment, or you can move to open, which is timeout, drop, user dropped off, failed payment. Oh, it's not failed payment. Yeah, drop. Failed payment, you keep going back to the logged. Yeah, so that's another state transition. From open, you can't move directly to booked. From booked, you can't go anywhere. Booked is the final state. So Nived said that log that is a good idea. Why is this a good idea? Because now you can unlock based on when it was previously logged. So let's take an example. Gaurav books the seat right now at 17:36, okay, Indian Standard Time. If you're going to give him 15 minutes or 10 minutes, then at 17:46, we know that this seat, which was logged at 17:36, is no longer locked. So when you do a get request, get seats, and I get this list of seats, I get all the seats, their IDs, their event ID, the description, the status, and I treat all seats which have been logged before 10 minutes as open. It's as good as open. Okay, so when you do a get request, that's how it goes. Is this making sense? Because there is no way that a seat which was logged more than 10 minutes ago and has not been booked yet is going to be booked later. Yeah, okay. Let me look at some of the questions on the chat. Guys, take your time. If you have more questions, you can just post it now. Status unlocked. Unlocked is not necessary. Open is sufficient. Or you can say unlocked. Yeah, open can be called unlocked also. Good point. When the user is clicking on book, then we can send them alerts that the seat is already booked. So we are not going to do that because it's going to be expensive on the system. It's going to be very cognitively intense for the user also. The user doesn't want to really see that other people are booking seats, and if it's relevant to them, they will anyway be affected later when they go to the payment page. If it's not, then they're going to go ahead anyway. Okay. So this is how we are expiring seats or expiring booking intents. We are during get requests being able to tell whether a seat is available or no by just looking at the logged at timestamp. We are not having a cron job running in the background which is changing the status. We are not having any other algorithm. This is a very simple algorithm which tells you that it's like a cache having an expiry. So when the lock is expired, you treat it like an open seat. You might want to even change the status or not. It doesn't really matter. The system is going to treat them similarly. Okay. Why can't we have a timeout function? In this case, we don't have to store logged at. But why do you want to have a timeout function? If that timeout function fails, if that node crashes, then you will not be able to run that function after the timeout. So instead, when you're persisting, when you're inserting or updating the record, that's when you do this together, atomically. It's an interesting question though. How do you auto unlock? Do you send all logged tickets in a queue to get unlocked and available? How would you implement it? So the auto unlock is happening in this way, because either all the seats are locked or none of them are locked. If all of them are locked, then they are locked at the same time. And the way that we are dealing with it is, when you're getting seats, you are checking whether they are locked or unlocked. So either they are open, or they are booked, or they are locked. If they are locked, then if they are within the time of 10 minutes, then good. Otherwise, you treat them like open. So Mayank is also mentioning that can we use a cron? It's not necessary, and it is just a little complex, right? Having a cron may miss, a cron may run at a different time, a cron may be put in a queue which is processed a little later. Maintaining state is another thing, like is a easier way to do this. You have basically two approaches. One is to use a function, whether that is a cron or a callback. So instead of that, we are going for storing state. This is easier in this case. Okay. But in this way, we don't have a list of open seats and book seats, which is needed when seat map page is displayed. Basically, how do we get the seat status API? So you do have a list of seats which are open, which are booked, and which are locked. So when you get the entire, let's say there's an array that you get back, all seats which are booked, opened, and locked, you get everything, all the details. Along with that, you get the timestamp when it was locked. Okay, all the seats which have been locked and the timestamp. If the timestamp of locking was more than 10 minutes ago, then you treat it like open. So open. This is actually logged within the last 3 minutes. This is open because it was logged 15 minutes ago. Okay, then you have something which has never been selected. You have booked, open, locked, open. That's how you're going to get it. The server manages giving a response of logged or open based on the logged at timestamp. How do you unlock technically? Do you spawn a process? Can you delve into implementation in detail a bit? So it's never going to be unlocked. That is important to understand. The status column is never changing from logged to some. It's only going to change from logged to booked. Okay. If you have a seat which is open and someone makes a book API request with that seat, then it's going to move from open to logged, and logged at is going to be stored. Once it expires, if the person does not go ahead with the booking, this booking fails, the next person who's making a booking with that seat is going to update the logged at timestamp. Okay. If they successfully book the seat, then it's going to move from logged to booked. Take your time. It's not very difficult to understand. I'll maybe show a state diagram here. When there is a timeout or a drop, the seat status does not change. Nothing changes. The database entry does not change. When a user does a get query, they will see the seat as open if it was logged earlier, more than 10 minutes ago. Okay. When they make a book request on that seat, it will stay on locked. Only thing that will happen is logged at will get updated to current timestamp. Is this making sense? Yes. So Aryan, that's exactly right. It should either be open or the logged at should be more than 10 minutes ago. Both of those conditions are treated like open seats. Yes, Nived, yes, that is also correct. Fetch where open or now minus logged at is greater than lock duration. Yes, I guess Nived and Aryan explained in 2 sentences what I was doing for 15 minutes. So thanks for that. Okay. Is there any disadvantage of using delayed Kafka consumer with a delay of 10 minutes? There is no advantage, Aditya. There is a disadvantage. You may see the event getting delayed or processed a little later. There is no need to bring in that complexity. This is a much simpler way to do it. How do you handle the race condition? Okay, so this is great. Heisenberg, you have gone for the second point, which is perfect. The first challenge we had of expiring seats is taken care of. The last challenge is managing race conditions. What if two people are trying to book seats at the same time, the same seats at the same time, overlapping seats? Okay, so what can we do? In this case, even if you don't, like if you want a quick reminder before an interview or something, or you want to do this at work, there's a blog linked in the description. I'll just describe the techniques there, which is maybe 90% probability of what is actually happening in the real world also. Okay, so I'll explain the 3 algorithms which you can use to avoid concurrent bookings. That's the challenge. The challenge is Gaurav, Heisenberg, and Aditya, all 3 like a particular seat. They came, they saw the seat arrangement. Gaurav said, I want to sit here. Book it for me, please. So Gaurav makes a booking request. Heisenberg, at the same time, because it's a Coldplay concert, bookings are happening simultaneously. Heisenberg does the same booking request. And Aditya is very rich. So what he says is, I'm going to book all 3 seats. So he has one overlapping seat. He wants 3 seats, but Gaurav and Aditya are now competing for seat number 2 here. Okay, in row C. So Aditya wants to book 1, 2, and 3 in row C. Gaurav wants to book C2, and Heisenberg also wants to book C2. Okay, so 3 bookings have come, 3 overlapping bookings. How do you manage this? What are some ideas around this that you would have? We mentioned locking earlier as a potential solution, but what else? What else can we do? Would locking work? So when you're updating the seat status, when you're updating this particular field in a seat, in an object, in memory, if you take a lock on that object, would this work? Shanky, we have discussed that question. You can look at the recording a little later. We'll describe how that happens. Abhiram, you are right, but no. In a sense, you need to know whether the seat is booked or not. So logdat can take care of open and locked, but it can't tell you whether the seat is can't be locked anymore. Okay, it also makes it easy to think of. Tomorrow if your algorithm changes, if logdat is no longer necessary, then you don't go like, oh no, I didn't have a status only. You have a status also. Okay. Coming back to the question, would taking locks on status in an object work? A seat can be associated with multiple shows. No, Rajat, we have clarified that in the start. A seat is associated only with one show. So if Gaurav walks out, he sits on seat 34 and he walks out, and then Rajat comes back and sits on the same seat, seat 34. Because they are different events, they will have different IDs. Those seats will have different IDs. You can imagine the seat ID to be something like event number 123, seat C34. And when Rajat comes, it is event number 124, seat C34. And these are the seat IDs. So every event has different seats. Every physical seat has different ID. Yes, so Rakesh is right. On every click of the book event, on this event number 1, we are making a API call to booking intent. But if 3 people have made concurrent booking intent API calls, how do you manage this? That's the challenge. right? Gaurav made this booking. Another person, Heisenberg, said no, I want that seat. Okay, and his user ID is, let's say, 456. And then a rich kid named Aditya, I'm just kidding, says, I want to book the seats, I want to book 3 seats, and my user ID is 999. Okay, all 3 booking intents have arrived on the system. How do you manage this? In a simplistic, yes. So Harry, that's brilliant. One simple approach is to put these booking intents as they arrive on our server in a queue. Okay, so let's say this is request number 1, request number 2, request number 3. It doesn't matter how we process it, as long as we force ordering amongst all these requests. So we tell them to go in 2, 3, and 1. So request number 1 is processed first, which means this request passes. Okay, 3 and 2 wait. Once this is done, 3 and 2 are picked up. So 3 is picked up first, 2 waits. What happens here? 3 tries to make a booking. The booking for seat number 1, 3 is 1, 2, 3. It tries to make a booking for 1, 2, and 3, these 3 seats. It sees that there's a clash already. 1 seat is already locked. This is not going to work out. 3 fails. Now 2 is processed. 2 looks at seat number 1. Seat number 1 is already locked. 1 has already executed. So 2 also fails. Basically, if you put all booking requests in a queue and process it in FIFO order or in any order, it doesn't really matter, as long as you are able to force an ordered execution for events, things will work out fine. Okay, there won't be double booking, there won't be overlapping booking. So a simple way to think of this is a FIFO queue. You could also have the bookings come in as 3, 2, 1. Maybe when you sent it, that was fine, but the server has processed it as 3, 2, 1. Maybe the gateway, when processing the request, passed 3 first. Doesn't matter, right? Because you don't have any favoritism towards any user. Whatever order you receive them on the server is the order in which you process them. You process them one by one. You don't process them in parallel. You don't process them concurrently. Process them one by one. And so you are sure that there is no double booking. Okay. Yeah. Aryan, you're right. One queue can be a single point of failure. That's one thing. Any other problem, guys, that you can see here? Aryan, you have already read the blog, so you probably already know. If this queue fails, then there's a single point of failure. But because let's say you have a single server also, and you have a queue, the chance of a queue failing in a single server is low, because it's software. So as long as the server doesn't fail, it's highly unlikely that the queue is going to have any issues. You may run out of memory, in which case you can consider it to be a server crash or an app crash anyway. Any other issue you can think of? Let's say it's Coldplay and the concert has thousands of tickets and tens of thousands of customers are interested. Think of a physical queue. How long is that going to be? Or at an airport, you have an international flight, immigration, one queue. What's going to happen? Yeah, Heisenberg is right. It makes the process extremely slow. One person managing all tickets, one queue managing all tickets means there is only one thread or one processor which is processing, and it is happening in synchronously. So each request is processed and then the next one is picked up. What happens here? The queue keeps getting longer and longer and longer. The processing time has to be faster than the enqueuing time. Yeah, that's not going to happen here. You will not be able to process requests very quickly. So what's going to happen is that this queue is going to get longer and longer. Eventually, many of these requests, by the time they reach the front of the queue, will have timed out. They will have missed their flights. The request would have been timed out. The client is going to retry and add themselves to the end of the queue. So this is going to lead to a very slow system, which is eventually going to collapse. Single queue will not be able to scale. Okay. Any other, okay, we know enough problems around the single queue. What other solution can you do? What other solution can you try? Yes, Sheikh has a very interesting point. Can we have multiple servers serving the booking intent API call? If yes, that would not work, right? You are right, Sheikh. It would not work if we do it in the naive way, but that is the way to go ahead. You have given us the right idea. You have multiple counters or queues now. So you have multiple, let's say, processors. So you have scaled horizontally now. And this queue is now going to be processed by this processor. This queue is going to be processed by this processor. This queue is going to be processed by this processor. So the wait times have reduced. You have been able to split your requests into multiple queues. Maybe you're using multiple threads. So if you have a quad core or a dual core, if you have virtual CPUs, then you can use them to process multiple queues. Do you see any challenge here? The earlier point that we had, that double bookings are impossible, is that still true? Let's say Gaurav makes a booking for seat number 1 here, and there is a booking for seat number 1 here also. Is there any guarantee that both of them will not be processed? This processor is going to look at Gaurav's booking. They're going to look at the seat arrangement and the current booking statuses, and they're going to say, wow, that looks nice. Let me book. How do you tell this processor that Gaurav is booking this seat? You'll most likely take a lock, or some sort of distributed consensus will be done. Okay. I think someone mentioned also distributed lock. So this is going to be a bit, this is fine, it's possible. Okay, it will work. There's no problem here. All you have done is moved the lock acquiring to a central place. All of these threads, all of these processors are now acquiring a lock in some central server, which is doing the booking. It's okay. It's not too bad. But can you do better? Can we do this without locks? Yeah, Rizwan, you're right. Each process or thread should have knowledge about the logged seat IDs. In case a person makes a booking, then they will have to notify the other processors or threads about the newly logged seats. Either they tell that physically, or they keep a central store where all of them can go and read about it themselves, right? So either you take a lock on this seat so that others can't, or you go and notify them. Notification is just going to be very, very intense. So we are not going to do that. Inter-processor communication, we are not going to do that. It's going to be even worse than just changing the state in the central area. But the central area itself is not very good. So can we do something else? Can we remove the need for locking? Can we have lockless bookings? If you have lockless bookings, the benefit is it makes the system simpler, and it is also usually more performant. Can you do that? Transaction isolation level serializable. Harry, that will work, yes. But all we are doing is we are moving the problem to Postgres. It would be fine. It would be fine. The only thing is once the processor is processing, it's going to hammer Postgres, and all the problems of locking are now moving to Postgres. It is going to be a little slower, Postgres. But it's good to move the contention to the database level. It's not a bad idea. That practically it might help. Is there a way to make sure though that Postgres is never going to have two bookings for overlapping seat arrangements? Shubham is mentioning IRCTC way of ticket allocating. So Shubham, can you describe what that is? Yes, lockless would be great. Yes. Will it be a complete DB lock? It could be. You could have locks on the DB, but I'm saying that you don't need locks on the DB also. I'll give you a hint. Can you think of routing or reverse proxies? When you have requests come into your system, how would you route these requests? Can you use some sort of an algorithm to route requests efficiently? Right. Just give me 1 second, guys. There's someone at the door. I'll just open it and come back to you in a minute. Till then, you can think about this problem. Yeah. Okay, I'm back. And yes, it is. I think I ordered milk or something. Yeah. After these 1 or 2 hour long sessions, right? It's pretty intense on the throat. Minimize contention by allowing subset of seats to be booked by each process. Bhavin, that is correct. Yes, that is absolutely right. We'll explain that in a minute. Assign processor with specific seat range via Zookeeper. Akshay, that is also correct. That's really good. We can shard the queues to each processor so that there is no overlap of seats between processors. So Julius, Akshay, Bhavin, you're absolutely right. I think Abhiram also has the same idea. You can use Zookeeper for this. It's really good. Okay. I see some other ideas also. Can we think of implementing immutable status? Okay. Can we use cache eviction to take the lock? Right. Let's focus though on Bhavin and Akshay and Julius and Abhiram's idea. Let's see if that works. Okay, and then we can go for the other ideas also. Lockless bookings. What do we need to do for this? We saw earlier that when we have a single queue, we can have lockless bookings because everything is synchronous. Every booking goes into the queue and one by one it is processed. So there is no need to take a lock. It's as long as you process them sequentially, nothing really happens. Harry also mentioned in between that you can have serializable isolation level in Postgres. That will also work fine. How do you bring the best of both worlds is this way. You need to route the requests correctly. So if you route the request on an event ID, then things should be fine. Okay. If you route the requests in that the Coldplay requests are going to one queue, which is being processed sequentially, and Gaurav booking a movie theater in some other place is going to be processed sequentially, and someone else listening to a cricket going to a cricket match is going to be processed sequentially. So based on event ID, you shard the queues, and whenever a new event comes, whenever a booking comes for a particular event, you find where to route this request based on the event ID. So let's say event ID is 5, 6, 7. You have 3 queues. You do a modulo 3. What do you get here? You get 0. So let's say these are the queue indexes 0, 1, 2. This request for 567 will go to the queue 0. Okay. Where does 568 go? Modulo 3 will give you 1. This request 568 then will go to queue number 1. So for any event ID, for all the booking requests that you have for any event ID, they all go and land in the same queue. In this way, you're able to split, you're able to ensure that all the booking requests for a particular event land in the same queue, which is good. So they'll be processed sequentially. You don't need locks here. But at the same time, you're not keeping all the events, all the booking requests for all the events in one single queue. You've split it up. This is idea number 1. Can you think of any other idea? For an event like Coldplay, where there are thousands and thousands of events in a single queue, what do you do? Firstly, is this idea making sense? You're able to split the bookings into multiple queues. Yes, Rajat, that's correct. Request with the same seat ID for a particular show should always go to the same queue. There is a problem there. If you're booking ranges, if you're booking 1, 2 and someone else is booking 2, 3, then how do you know that these 2 seats are in the same, can have contention? Shravan, you're right. It is still the same problem. The problem has reduced in scope because different events are now going to different queues. But if there's a very big event with thousands of seats, you still have a problem because everybody's trying to book that event. But can you use this idea to distribute the events, distribute the requests? If there is a large number of seats, we can shard based on seat IDs. Okay. So Sheikh, can you explain how that's going to happen? Remember that people may be booking in ranges. Orchestrator Saga. Share based on sections of the stadium, for example. Yeah. Ahmed has now hit the nail on the head. I think this is the answer. Share based on sections of the stadium. What happens when you're trying to book seats? Just give me another second, guys. Yeah, I'll just open the door again. That's an interesting problem. Alright, I'm back. If you have ever gone to a cricket match or you've gone to a music concert, you will notice that the seats are not all put together. There are gold seats, platinum seats, stand seats. There are various categories of seats. Is it possible to have overlapping bookings across categories? No, you can't. Okay, you can't have 3 gold seats and 2 platinum. Okay, or is it possible? Let me look in the comments. Would you allow that for a Coldplay concert? Right. Yeah, so if you're sharding based on sections, what happens if a booking is spanning across multiple sections? Will you allow that in a Coldplay concert or in a cricket match where there are thousands of seats? Remember, when you come to the screen, what you do is you mention the number of seats you're buying, but you also, when you're booking a movie, but when it comes to a large event like Coldplay or a cricket match, do you actually get to book across sections? Right, we can restrict those type of requests. When you have a large stadium and you have various sections, I have not seen a stadium which is allowing you to book some seats here and some seats here. That's not, yeah, exactly. You can't. Does not allow booking across sections, right? So, and the reason for that is because you need some sort of key to send to in a queue. Otherwise, this sharding algorithm is going to get too complex. You can of course go for this simple single queue per event. That would work, but it would be better if you're able to split it into regions. And Julius, you have just confirmed that. In my experience also, you're not allowed to book across sections. In a cricket match, you can't have 3 stadium simple seats and you can't have 4 platinum seats in the same booking. You can do that separately. Do 2 bookings. That will be their response. Okay, so now this queue can be split into multiple pieces. For the same event, you can have one for platinum, another for gold, and another for regular. I think they have names now, interesting names to sell, but this is the idea. You're now able to split into further sections. Okay, great. This would most likely work. Is there any other thing we can do for very large events with thousands of seats? I think at this point, when you're looking at this is enough for movie bookings. There's never going to be a crazy rush for booking movies. We are looking at the cases where there are events, large events. This would suffice for many events. What else could we have done? Something that IRCTC, which is the Indian train booking system, does. Okay, I'm not talking about refunding seats. We'll still have to keep the same flow. But do you get to choose seats in IRCTC? Do you get to say that I want to be on this coach in this seat? Or does it book it for you? And is there any advantage of the system booking the seat for you? Not as a customer. Of course, as a customer, you don't need to think then. Life is easy. But any other advantage for the system itself if it can book the seat for you? Let's imagine a stadium. No, Abhishek, it absolutely, there is a clear advantage of doing that. If you have a stadium and you have these sections, okay, I'll just label them by alphabets: A, B, C, D, E, F, G, H. If you're booking in section A, I can either ask you to book the seats, the exact place to book, or I can just tell you, give me the number of seats you want to book. So 5 seats. I'll book it for you. Okay, I can do that also. It could have been done for Coldplay. It could have been done for large bookings. It's possible that these seats are going to be all around the place. Okay, your experience as a family is not going to be very good with 4 people sitting in separate areas. But that's okay. That's never going to happen, because whenever you're booking, you're going sequentially. Your system is going to be booking all seats together. So when you book 4 seats, you're going to get 4 open ones. Okay, your system can manage the arrangement. So as you're making the bookings, they keep going ahead. If someone cancels their seat, which I don't think your system should allow, but even if they do, then you shift all the remaining bookings back by so many places. Okay, this is something you can do if you are booking the seats or if you are allotting the seats to the customer. Yeah, exactly. Abhiram has it correct. It's the advantage of defragmentation. You can do defragmentation. You can allot the seats by yourself. If this was allowed, then life would be simple. Okay, the customer doesn't need to know. The customer has booked 5 seats, they're going to get all 5 seats together. If they don't, right, that is firstly not possible. You can't overbook in region A, but it's possible that you're going here 1, 2, 3, 4, and then the fifth one is in the next row. That's going to happen anyway. That's unavoidable. That's your problem. Yeah, the booking system does not care. Okay. Abhishek, that won't happen because you will have some sort of defragmentation happening. But if it happens also, it's not a very large problem. You have seen airlines also, when seats are booked, many people are able to talk to each other and get the seats of their preference. Okay, a family may go to somebody and say that, listen, you're sitting alone. Is it possible for you to shift? We have another member over there. That happens all the time, but that's not something that the booking system needs to consider. It's not our problem, right? Okay. Okay, guys, I think we have spoken about the booking system in BookMyShow in reasonable detail. The most simple algorithm, firstly, what we did is we looked at the flow. We looked at some of the API calls that we might be making. One of the challenges was to update the status of booking. We chose not to update the status. We chose to have a logged@at timestamp, which was, I think Nived came up with that idea. That was brilliant. Because of that, we had an easy way to view all available seats at any point, whether they are open or they are logged before 10 minutes, it's available. Once we solved that challenge, we looked at how do you avoid concurrent bookings, simultaneous bookings which have reached the server but are being processed right now. How do you avoid people from making overlapping bookings? So one idea was to use a single queue, which would be catastrophic. So instead what we did is we went for multiple queues. Instead of having a lock mechanism on the database or on the server, we chose to route requests in a way that you are sure that the servers are always processing non-overlapping requests. If one of these servers crashes, what are you going to do? I'll leave that as homework for you, right? That's a load balancing problem challenge. That's a routing problem challenge. There are many algorithms for this. Do let me know in the comments. But once you went for lockless bookings, we said that for very large events, you may still have a queue which is very hot. So queue number 1 has Coldplay, the other people have very little, so that queue becomes extremely long. The same problem of a single queue comes here also. At that time, we wanted to shard the Coldplay event by sections or categories. That helps further. And another idea is to completely take away the control that the user has over the seat that they are booking. The system books it for them. And so that way you are able to avoid fragmentation of users going in different areas. That choice is not necessary for such large events. And the second thing is you're able to make those bookings without having to look at whether the seats are overlapping, because you are now looking at count instead of seat IDs. Okay, so yes, in this way, maybe talking is easy. Implementing a system, like even a small startup like Interview Ready is a challenge for me. So BookMyShow is a much larger system, so I really commend the engineers there, and in IRCTC definitely, and Ticketmaster to be able to do this in the real world. But yes, idea wise this seems sensible. Manthan, no, I didn't. I didn't get the seat. Too bad. I didn't even try, but BookMyShow, if they would like to send me a seat, I would be more than happy. Yeah. Right, folks, any questions before we walk into the sunset? Thank you so much for tuning in. Thank you for joining this live event. It's an exciting piece of real world system design that we came up with today. And if anyone is working at BookMyShow and wants to add their thoughts, please feel free in the comments, or you can let me know on LinkedIn. Right, it would be interesting to talk about. But thank you for spending your Tuesday evening with me and looking into system design. I'll see you next time. Have a great evening. In fact, if you want to read more about this, there's a link in the description for a blog. I have written that around causal ordering and this kind of lockless bookings. How do you do that? So that blog describes it with images and detail. Here I have drawn it. So if you want a very short summary which explains the whole thing quickly, there's always a blog for this. Thank you, Harry. Thank you, Sheikh. The next session, I'm not sure, Sheikh. I'll just look at when I can host it. I think it will be next month soon enough. So that's good. Thank you everyone. Thank you for making this possible. I'll see you.